Hey guys, so I am here to talk a little bit about limits. This is limits day 1, so we're talking about graphically how to evaluate a limit. And you guys already got your notes on it, so I'm not going to go through and explain all the notation and everything. I'm just going to do a few problems with you. So the biggest thing I want you to think about when you're thinking about limits from a graphing standpoint is that we're talking about approaching. Okay, so if I look at a graph and I say, hey, what's happening to the graph as I approach this x value? That's what a limit is. So when I say in this first problem, what is the limit as x approaches 0, and this negative means from the left, what I mean is, where is the graph going towards as I approach 0 from the left on the x-axis. So like this is the x-axis and I'm approaching 0, which is right here, from the left-hand side. Now this graph is a little bit off. This big black dot is supposed to be right on 0, 0. So we're just going to pretend like it's just a little bit north of where it actually looks like it is. And that's the answer. The graph is approaching the y value of 0 as we come in from the left side. So this answer is 0. What about when we come in from the right side? So when I come in from the right side, what is actually happening to the graph? The graph is coming in this way, and it's also approaching that point right there. So it's also approaching 0. Now, if these two numbers match, so if the left limit and the right limit match, then the overall limit, which is not going to have a plus or a minus here, it's just the number as we approach 0, is going to be whatever that matching number is. So since this graph is coming into the same number from the left and the right, the limit does exist, and it exists at that value. Okay, so this next part is totally a different question. This is just evaluating. So what is the actual value? What is the actual y value when x is 0? That's what this means. Y equals question mark when x equals 0. So let's see. When x is 0, y is also 0, so this number is also 0. But keep in mind that it won't always be the same numbers for all of these, okay? So let's try the next one. All right, let's go to -3 from the left. Okay, so -3 from the left. -3 is right here. So as I come in from the left side, what is the graph actually doing? The graph is going down this way. So that is going down to -infinity. That's the answer there. It doesn't matter that the graph is never going to touch -3. It just matters that it's what it's approaching as we get closer to -3. And the same thing with the other one. So as we get closer to -3 from the right-hand side, the graph is going to go down and it's going towards -infinity as well. Since these are the same, the overall limit as x approaches -3 is -infinity. Now, what is y when x is -3? Well, there's a problem. There is no y value when x equals -3. There's an asymptote there. So that's a no solution, or it does not exist, okay? Because there is no dot on -3, but that doesn't mean that the graph isn't approaching -3. All right, let's try this again. I'm going to kind of clear out this graph. Limits are kind of abstract, so you really have to think about it. As we go to +3 from the left, what's going to happen? Let's see. +3 from the left. So we're coming in this way. So the graph is going towards this hole, okay? And so, again, this graph is a little bit off, so we're just going to say that this hole is right here at +2, okay? So the graph is approaching that. So we are going towards +2 from the left. From the right, what's going on? Let's see. From the right, we're also approaching that hole. So we're also approaching 2. And since those numbers are the same, the overall limit is going to be 2. Here's the weird thing. What is f of 3? Well, at x equals 3, there isn't actually a y value. Aww. There is not actually a y value. There's a hole there. So that value doesn't actually exist. The actual evaluation is a no solution, or there is no actual dot there. All right, uno más, one more, and hopefully it'll resonate a little bit better with you guys if it didn't before. Okay, 5 from the left. So from the left-hand side, as we get closer to 5, we're approaching this black dot. Okay, let's call it 1, 2. We'll call it up at 3. Okay, so from the left, we're approaching that black dot, which is y equals 3. So whenever we do limits, the answer is the y value. From the right, we're approaching the hole. Okay, so that hole is up at 3, 4, 5. I don't think Dean likes limits that much. Notice that these numbers are not the same, which means from the left and the right, the graph is not approaching the same number, and that is what makes this answer does not exist. So the overall limit doesn't exist because the function's not approaching the same thing from the left as it is from the right. I always think of Lindsay Lohan, the limit does not exist. This is a perfect example of the limit does not exist. Okay, it's not approaching the same number from the left as it is from the right. If I actually evaluate f of 5, what is the actual y value when x is 5? It's the filled in dot because that's inclusive. So f of 5 is 3. Okay. Hopefully that helps you guys out a little bit. Limits can be abstract, so I just want you guys to really think of it. It's an approach. Where is the graph approaching? And remember, that's different than where the graph actually exists. We're going to do this stuff algebraically too, so it's going to be lots of fun. Get ready for it. We'll talk then.